Hi guys. So that last video was way too long. We're going to try to do a little better, cut things up into more manageable sizes because I know you don't want to listen to me for 20 minutes. I don't want to talk for 20 minutes. Okay, so this is where we left off last time, or at least this was the next slide. We get set up here. This talks about electric power. So anytime we have a battery or a wall outlet, what have you, supplying current to some circuit, then it's also got to be supplying power as well. The way we calculate power is, well, power is current times voltage. So if I were worried about the total power that I'm using up, then I would need to know the total current being supplied and the voltage that's being used to do so. And just to remind you guys, power is what? Energy divided by time. And one thing that we can do, let's see, if we, one thing we can do, if we recall Ohm's law, and Ohm's law says V is equal to I times R, is we can plug this guy into our power equation, well, wherever we want. If we plug the V in, then we get what? P is equal to I squared R. Instead, if we rearrange Ohm's law and solve for I, so I then would be what? V over R, and then plug that in to our power equation where we get power is equal to V squared over R. So we've got a couple different forms of the power equation there that we can use depending on which one will be the most useful. All right. Get rid of this and let's see, let's not, okay. Now I'm playing with fire. I don't want to do that. Let me just clear all here. There we go. Okay. All right, and let's move forward. Cool. All right, so this problem says that we've got a 100 ohm resistor and that this 100 ohm resistor is attached to a 10 volt battery. And we're asked to calculate what is the current through this resistor. And then also how much power is the battery delivering to it. So there's our 10 volt battery. That's kind of a messy. Let me see if I can maybe just erase this a little bit, maybe redraw here. So y'all thought my drawings in class were bad, huh? Yeah, you haven't seen anything yet. All right, so this is not bad though, as far as the problem goes. We'll rearrange Ohm's law. Ohm's law gives us current is equal to voltage over resistance. It's 10 volts total. That's 100 ohms total in our circuit, for resistance in our circuit. So now that gives us a current of 0.1 amps. And there's our answer for that. The other thing this question asks is, well, what's the power delivered to this resistor? So we can do this a couple different ways, but I'm going to look at this one right here. And specifically, why did I choose that one? Well, because I'm not quite sure how much voltage the resistor uses up. I mean, honestly, I can probably guess it's 10 volts, and you guys know that. That's fine. But I do know exactly how much current is going through that resistor. It's 0.1 amps. And I know that the resistor has a resistance of 100 ohms. So as a result, what do I calculate here? I calculate that the total power delivered to this resistor is 1 watt. Now, of course, I could have just gone ahead and done power is equal to current times voltage. What's my current? 0.1 amps. What's my voltage that resistor is using up? That's 10 volts. Whoops. Eraser. There we go. That's 10 volts. So this gives me 1 watt. So either way, let's move forward here. And apparently I didn't get the clear all. Okay, let me clear all. Okay, so I've got a clicker question here. Guys, I want to remind you that I would like you to pause and think through this yourself. Okay, so specifically, this problem asks us about a space heater. It says that we've got electrical outlets that supply voltage in the amount of 120 volts. And then it tells us that the maximum safe current that we can have is 18 amps. Okay. There's circuit breakers or fuses that prevent the current from going over 18 amps. That's a safety feature because when wires get too much current through them, they get hot, and then we've got a fire hazard. So if that happens, then that's the circuit breaker is tripped. So this might happen if you've got too many things plugged in at the same time. For instance, hair dryers are well known for tripping circuit breakers. All right, so this problem asks about how many space heaters can we safely plug into a single outlet. And it says that each space heater draws a total power of 1,500 watts. Well, given the numbers that we have here, what is the maximum power that we can have? Well, the maximum power we can have is a function of exactly how much current we can have safely times the number of times, the voltage that's driving that current. And when I do this out, this looks like 2,160 watts. So given the fact that one heater takes 1,500 watts, that means that we're going to be limited to just one heater because there's not enough to supply two heaters. And let's see if I agree with myself. Yes, I do. Fantastic. All right. Next question. Okay, this one's a little dated. It says we've got a CD player, and this CD player has some special power saving technology. Well, that's great. It says that this CD player is being supplied with voltage from two AA batteries. So the total voltage is 3 volts. And that those AA batteries supply 20 kilojoules worth of energy. With that 20 kilojoules worth of energy, this player can be played for about 25 hours. So based on this information, what's the resistance in the circuitry of the CD player? All right, pause this video, guys, and try to work this out for yourself. Okay, so I've given myself a blank sheet of paper to work on here, and we'll see if I can get this. All right, so well, I'm in red. That's not good because that means I'm actually drawing on the slide, but that's okay. We'll stick with it and hope I don't make any mistakes. So it says what? That our voltage is 3 volts, and we don't know what the resistance is. That's actually what we would like to solve for. It says that we've got a total energy available from those batteries of 25,000 joules, 25 kilojoules, so that's 25,000 joules. It said that we can operate this for a period of 25 hours. Now, of course, you guys know that we don't operate in hours, we operate in seconds. So if we convert that to seconds, we get 90,000 seconds. Great. So let's see, with that information then, we can figure out what the power is because we know that power is equal to energy over time. Yeah, you thought my handwriting was bad before. The stylus is doing the best I can here. 25,000 joules over 90,000 seconds. Looks like 0.222 watts. Okay, so there's our power. That's great because now with that power information and with the fact that I know what my voltage is, I can use one of those three equations for power. That power is equal to V squared over R to figure out what my resistance is. So rearranging this equation would give me resistance is equal to V squared divided by power. That now is 3 volts squared over my power, which is 0.22 watts, gives me 40.5 ohms. So if you pick choice A, 40 ohms, let's see, if you pick choice A, 40 ohms, then you were right. Okay. Oh, sorry. Yeah, trying to make sure that I can write on the screen and so on and so forth. Hopefully that didn't go up my nose. I'll talk to you all later.